Hi, everyone. Welcome to today's online summit, DevOps and Your Cloud Infrastructure, Getting Started with Digital Transformation. This event was organized by the hardworking folks at 1105 Media Publications, Redmond Magazine, Virtualization and Cloud Review, AWS Insider, and Application Development Trends, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, Zerto, the company that brings together disaster recovery and data protection in a single scalable solution to provide simple cloud data management and protection across on-prem, hybrid, and multi-cloud environments. Without them, this event would not be possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of the Converge 360 Group of 1105 Media, and I'll be your moderator for the first of two information-packed sessions. But before we get started, a bit of housekeeping. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsor has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. At the end of the summit, you'll be asked to take a very short survey. Please take a moment to share your honest opinions. Our editors actually read every comment. I'm one of them, so I know it's true. Your opinions help us to shape our future events. And last but not least, at the end of the second session, one lucky attendee will be receiving a GoPro Hero 10 waterproof action camera with front LCD and touch rear screens, Ultra HD video, and 1080p live streaming. But you must be present to win, so stick with us. Now let's get started with our first session, Digital Transformation, DevOps, and the Cloud 101 Transformation Basics. For our first session, we've called on technologist, creator of compelling content, and senior resultant, Howard M. Cohen. In his 40-plus years in the IT industry, Howard has held senior executive positions in many of the top channel partner organizations, and he currently writes for and about IT and the IT channel. Howard is a sought-after speaker, an insightful observer of the technology landscape, and one of our very favorite presenters. I know you're in for an awesome session. Take it away, Howard.
Thank you so much, John. And hello, everybody. Welcome to Digital Transformation, DevOps and the Cloud 101. Transformation Basics. We are going to review the basics of creating transformation in the heart of this session. Now, since it's multiple topics and we're talking about basics, let's get started unpacking all of this and begin with digital transformation itself. Okay, here we go. Now, those of you who have ever attended any of my sessions know that as a writer, I like to start each session with a word of the day. It's just a thing. And today's word is continuous. Continuous. Now, you may be wondering, what does continuous have to do with digital transformation? And rest assured, I'm going to tell you. And so to get started with that, let's jump right into transformation basics. Number one, the first basic of transformation is that it's not about technology. Everybody thinks digital transformation is primarily about technology, and it really isn't. The object of it is people. It's about how technology can be applied to improve how people do what they do, accelerate what they do, make it better, more fun, and faster, certainly, and make it more gratifying, make it, more rewarding by freeing up people from the repetitive stuff and getting that out of their way so that they can do much more interesting work that taps into their innovativeness and their imaginations. So digital transformation is really a very, very good thing if you think of it as something that really benefits people and the people that they work for. So to give it, in a short bite, digital transformation is about people more than technology. Okay, that's transformation basics number one. Might as well jump in again and start with transformation basics number two, continue with. transformation basics number 2, which is that digital transformation, here's the magic word of the day, continuous. It's a continuous, ongoing process meant to constantly produce better and better results. It's not just a moment in time. It's a process that you commit to that's going to keep going, just like this perpetual motion machine on the screen. It just keeps going and going, kind of like the Energizer Bunny. So if you want to remember this basic, remember, digital transformation is the Energizer Bunny. Okay. And to put it into short bites that we can remember, you don't do a digital transformation. You've heard people say, we're going to be doing our digital transformation. That's impossible. It's not a moment in time. It's not a singular event. You're in a continuous, ongoing process of digital transformation on an ongoing basis. A company that is in digital transformation is constantly getting better at what they do. So it's not set it and forget it, as so many things are supposed to be out there. One thing I want to dispense with is the idea that digital transformation happens when we replace our existing computer equipment with new computer equipment. That's not a digital transformation. That's very simply an upgrade. So let's not mistake an upgrade for digital transformation. It's a much more long-lasting, ongoing process. Okay, so now that we've taken a good look at digital transformation, we understand how we're talking about it. The definition I've given you is my definition, certainly, but it'll be the definition we'll be using for the rest of this session. Next up, let's take a good hard look at DevOps. In the beginning, before there was DevOps, there were developers, and those developers did what you would expect software developers to do. They would go into a company, find out everything they could about it, what their operations look like, what their processes are, where there are weaknesses, where there are strengths, where there are opportunities, where there are threats. They would gather all this information, and then they would create a functional specification for the application. And once everybody bought off on that and signed off and said, yep, that's what it is, they would then create code. They would create programming code, and they would do so in one big block or monolith. Today, we refer to that style of programming as monolithic code, because literally everything that the program is able to do is in that block of code. It's in there. It's part of the whole thing. Now, that sounds great. It's all self-contained. Isn't that fantastic? And the answer is no. Actually, that's not so fantastic. We found out after long, hard, painful experience that when something goes wrong in the program, if a given command fails to execute, if something breaks, the entire program stops in many cases. There are some times when some things can keep going, but not often. Usually the entire system is brought down and all the people using it go into thumb twiddling mode, which is something we never want to see them do. So the developers develop blocks of code that we call monoliths today. They would then take those blocks of code, by the way, and give them to the computer operators, who would load them into the system, get them going, deploy them, and then let the users know that they can go and do what they do, which is to use the applications. Now, these were the three primary players in the process: the developers who created the code, the operators who ran it, the users who used it. There are certainly trainers involved who train the users to use it. There are managers and supervisors involved, all kinds of other people. But these were always the three core players. Now, once the software was deployed, the next thing that would happen is we would just wait and wait. Time would pass slowly, horribly slowly, while we waited for the next update to come to improve the software, or the next upgrade to radically change the software, or even just little patches to fix things that aren't exactly right in the software. It could take a while. And so it was frustrating because you'd have to figure out how to work around them until somebody came along and delivered you an update, an upgrade, or a patch. This was painful. So between this and the vulnerability of a monolithic program, we realized that at some given point, we'd have to be rid of the monoliths. This was just not a logical, sustainable, resilient way to proceed. So we traded in our monolith for microservices. That is to say that all of those tasks and commands and functions that were embodied in the monolith, in that big block of code, were completely broken out into individual microservices. Each task, if you look at these 8 blocks I'm showing you, each one represents a task, a singular task, and they have no relationship to each other. They come when they're needed. They come when they're called. They're kind of like the cavalry. And so we took these microservices and we put them into containers. Let me show you what that looks like. Okay, so we take our microservice, we put it into a container, and we give it all the resources it needs to run. Now that is a completely self-contained instruction, a task, a service, a function. Whatever you want to call it, it's individual. And the system calls it up, and here's what happens next. The system calls it up from the cloud. It then delivers a fully contained microservice along with its resources. Sometimes, every once in a while, one of those containers comes out broken, cracked, no good. And what the system does is very, very clever. It processes it and reinstantiates it. It creates a whole new one. Nobody ever even notices that happening. The system does not come down. The users are all continuing to do what they do because each of these little microservices is very loosely coupled from all the others. In the monolith, everything was tightly coupled together, and if one thing failed, other things connected to it failed. Here, if one thing fails, it's tossed and replaced with something that works, and we move on. Okay, so now we move on. Now, I have to ask you to utilize your imaginations here. Unfortunately, the next animation doesn't seem to be working today. So we would then take this container and it would fly off into the cloud to do what it was meant to do. Now, the sad part is that if this were working, you'd see containers flying, one after another, after another, after another. So I need you to imagine that the containers are flying right after each other and traveling all over the cloud to do what they need to do, where they need to do it, when they need to do it. Similarly, in this slide, that container is supposed to be followed by more containers to continue the animation, but didn't quite work that way today. So here's transformation basic number 3. Number 3 is that digital transformation is best enabled when you transition to cloud-native microservices in containers. This style of programming, putting microservices in containers and letting them fly all over the cloud, is referred to as being cloud native because it was really designed to take advantage of everything the cloud has to offer. So we're now dealing with cloud native microservices and containers. And by the way, it's not best enabled. I think the only way that you can accomplish true digital transformation at this point is if you have somebody producing your software using cloud native microservices in containers. So this brings us back to the beginning when we had our developers, our operators, and our users. And we now have DevOps, the second of our 3 terms. DevOps. DevOps, of course, is a compound word formed by adding the word dev from developers to the word op by ops for operators. No mystery there. DevOps. Developers and operators working together, closely together in most cases, using the same tools, if you will, practicing the same procedures in many cases. There's an alignment that gets created between the developers and the operators that keeps them as one working unit. And this is necessary, by the way, as you'll see as we move forward. Oh, this is good, right? My TV just decided to join us. Isn't that nice? Okay, sorry about that. Okay, so developers and operators working closely together to support the users. Let's see how that works. Okay, we're going to take a good hard look at the DevOps process, the DevOps cycle, which, as we've said, is composed of microservices that are traveling in containers, and we tend to refer to this style of programming as cloud native. Okay. So here's the DevOps cycle. Pretty simple, actually. It begins as it always began, with the software developers creating code. They write the programs that make the whole thing work, and they then deliver that software over to the operators. The operators then load it up into the system, they deploy it, make it work properly, configure everything the way it needs to be, and then they notify the users that, okay, you can now start using the software. And so the users do their thing, and they're using the software. Okay. Shortly after they start using the new software, the operators come back into the picture, and they go back out to the users, and they ask them how it's going. How do you like the software? Is it working for you? Is it doing what you expected it to do? What's not working properly? What could be better than the way it's working now? They try to find out as much as they can from the people who would know best, the people who are basically out there using the software. They take that feedback and they return it to the developers. Now the developers have the feedback, they go through it, and they use it to improve upon the code. They go back to the original code, they start to look at which places need to be improved upon to satisfy the feedback that the users have given them. Now, in cloud native, since they're working on individual microservices, multiple people can be working on multiple different parts of the program all on their own, and so you can actually repair several things all at the same time. And also, you don't really have to worry about finding the point in the big block of code where that occurs and what does it connect to, and let's be careful not to break anything while we're doing it. Cloud native software just doesn't work that way. It's easy to correct something and to change it and to improve upon it. And so they create another iteration of the software, which they then give to the ops people to deliver to the users. And yes, after the users have used the new software, they come back out for more feedback, and they bring that feedback to developers. Now, again, I'm going to have to ask you to employ your imagination, because in this animation, which just decided not to work today, that would keep going around and around and around and around and around. And that's exactly what the DevOps cycle does. It just keeps going around and around this sequence of events, time after time, to keep on iteratively improving the software more and more and more. Now, here's where we come back to that whole idea of constantly getting better, right? This is constantly getting better. The interesting thing is that it changes the way we look at things like upgrades and updates too. Whereas upgrades come out, what, monthly, maybe quarterly, maybe annually, and updates may come out weekly, but they could come out monthly, you know. DevOps updates come out several times per day. In many cases, dozens of times per day. In some cases, use Amazon as an example. Amazon issues upward of 200 software updates every single day. Every day. So, I mean, think about what that takes. It means that everybody's got to be firing on all pistons. You know, everybody's got to be cooperating, using the software, offering up feedback, doing everything that needs to be done so that we can keep on doing this over and over and over and over again. And so that's the DevOps process, going from planning to code, testing, releasing, and then deploying the software, using the software, and monitoring the results to start the cycle all over again. And it goes around and around and around and around. So we moved from ops to DevOps. Here we are at DevOps. At some given point, people realize that, this all has to happen a lot more securely. And they're right. So we incorporated security into it and called it DevSecOps. Now that we were comfortable compounding words together, we realized that, everything we're all doing is meant to support the decisions made by the business development group. So you probably guessed it, we now call it BizDevSecOps. And those of you who can say that 4 times fast will win a free Starbucks card, I don't know, something, anything. And so that's that process. You'll notice now that this DevOps process very closely resembles the CI/CD process. CI/CD. CI/CD stands for continuous improvement, CI, through continuous deployment, CD. And that's really what we saw happening when we went around and around the DevOps process, right? We were continuously improving the software and getting more feedback by continuously deploying it and having people use it and getting feedback from those people that we could bring back to the development team to take it to the next step. CI/CD, continuous improvement through deployment. And this brings us to transformation basics number 4. And number 4 is basically that the goal of DevOps is CI/CD. That's why we do it. The goal of DevOps is to achieve CI/CD that drives digital transformation. There's the whole ball of wax. Now, when we say continuous improvement, what are we talking about? What are we talking about improving continuously? Well, first and foremost, it's obvious that we're talking about continuous improvement of software, right? The applications keep getting better and better and better as we go through each iteration of getting the feedback from the users and bringing it back to the developers. But we improve the applications so that we can improve our operating processes, right? That's what applications are there to do, to make processes work better. And when we get all of our processes working better, we're now improving our overall operations. So now the company's operating much more effectively, much more efficiently than it ever has before because we've got better software supporting better processes. And of course, all of that is meant to produce some kind of outcome, some kind of results, right? And so we're improving our output. Whatever the output is of each given department, this process is meant to improve upon it so that ultimately we can produce better products, better services that will improve. And here it is. This is the ultimate goal is to improve the customer experience. Make customers happier, keep bringing them back for more and more. That's really what the goal of all of this is. And we're continuously improving all of these things using this process, using DevOps to achieve CI/CD, to drive ongoing digital transformation. What is the one element that is necessary to all of this that we haven't touched upon yet? Yeah, we kind of touched upon it. We need Tom Cruise to help. No, we don't need Tom Cruise. What is most important here is that we do all of this at speed. Has to be done quickly. This process only works when it's done quickly. And competition, market competition, demands that we move more quickly than our competitors. As they said recently in CIO, speed of business dictates how quickly any enterprise can achieve and maintain leadership in the market, especially those who are undertaking digital transformation initiatives. They are entering into a process of ongoing digital transformation. Gotta be fast. How do we get this entire sequence of events to move faster? And the only answer, the absolute only answer, is to create a DevOps culture in your entire organization. It is not enough for just the developers to be committed to DevOps or for the operators, even for the computer users. That's not enough. Those people, they have to be certainly, they have to embrace a DevOps culture. But everybody in the company really needs to embrace a DevOps culture, because then everybody's cooperating, everybody's contributing. If an operator comes back to a user and says, I need your feedback on the most recent iteration of the software, and that user said, oh, I'm sorry, I've really been busy, I didn't get time to really put it through its paces, I'm really sorry, I'll get back to you shortly. That's no good. That just doesn't work. We need to move and move and move and move. So any user that's not totally cooperative slows down the process. We basically have to have everybody in the organization pulling the rope in the same direction, with the same fervor and the same passion. And we've all got to put on game faces like this first guy has. I'm going to make this software better. This is how you create a DevOps culture. Now, let it not remain unsaid that a DevOps culture is just meant to create DevOps. There are many features of a DevOps culture, many benefits that come along with it. We have a dozen of them displayed here in this one little slide. I really wish that I could go through all of this with you today, but it would take up a whole lot more time than we have for the whole presentation. Suffice it to say, there are plenty of resources out there that you can turn to learn more about DevOps and DevOps culture. There are some great resources out there for that. Underneath all of it, the goal of any organization at any given moment in time is to increase revenue, right? But it's not just to increase revenue. If all you're doing is increasing revenue, you may find yourself with a nasty surprise at the end of a financial period when you haven't profited, because while you were increasing revenue, you weren't decreasing costs. See, those are the two levers that you get to pull and push to increase your profitability. You're either increasing revenue or decreasing cost, or, God bless us, doing both. Many people think it's impossible to do both, but they're wrong. You can increase revenue while decreasing cost by embracing DevOps to drive your digital transformation. Kind of the underlying reason we do it is because it enables this capability, increasing revenue while decreasing cost. From the standpoint of the developers, we're going to grow a shift-left kind of culture, also referred to as service ownership. And that basically says to the developers, you coded it, you shipped it, you own it. And they take ownership of the quality of the software and depend upon the operators and users to help them keep doing that. The shift left refers to catching problems earlier in the process, off to the left from the beginning of the process rather than all at the end of the process, further right. The sooner you catch an error, the sooner you discover that something's not quite functioning the way that it's supposed to, the better off you are. You save a lot of time and misery suffering through things until you finally catch up with them. So we want to shift left. Another component that's being incorporated into the DevOps process is AI, artificial intelligence, and machine learning too. We use these automated processes to make things faster. If there are things that humans have to do, like for example, if humans had to analyze a large database, unlikely they could do it very quickly. I mean, it's a lot of data, it could take a lot of time. However, digital agents, artificial intelligence agents, can go through that data very quickly and pull out all kinds of observations and all kinds of inferences and help to develop some decision making very rapidly. Okay, so we're using AI. Now, fair warning, the next thing you're going to see is a shameless plug, and that is that I have a column in John Waters' Application Development Trends magazine called The Citizen Developer. And every month we talk about these citizen developers. These are not software developers. They don't know anything about code. They don't know anything about how to put a program together. What they do know is how the processes work in their organization. They're very familiar with, they work those processes in most cases. And so they're more familiar with the processes than anybody. And they bring that to the table. What we need to give them is a tool that will allow them to actually create an application without using any code at all. So these platforms, and there are many of them, are referred to as low-code or no-code platforms, not to be confused with low-doc, no-doc loans, which spread all of us. No, low-code and no-code enable a typical person who understands processes to be able to move files around the screen and construct an application. It's safe to say that that application isn't always going to be everything you need, but think of this from the perspective of your developers, right? They're out there, they've got a stack of assignments that they just can't make their way through. So many demands upon them. Well, now, these citizen developers can hand those people programs, applications that are, well, they're baked. They're not fully baked, but they're further along the line than they would ordinarily start with, would be from scratch. Basically, the way I like to, I'm not big on sports analogies, but here what I say is that the citizen developer takes the ball into the red zone, and then the coders have to come in and take it over the line. So this is a benefit to the entire operation because people who know the processes are automating the processes. It's a benefit to the developers because they get some of the work already done before they get involved. And it's a benefit back to the company again because they get their assignments completed sooner. So citizen development is becoming more and more a part of DevOps and more of a contributor to the digital transformations that people are undertaking all over the place. Code is still a very big part of our lives. As a matter of fact, it's becoming bigger. You've probably heard of infrastructure as code, but you may not exactly understand what that is. So imagine that you're sitting at your self-service console for your cloud computing service. You use this cloud computing service, and as it happens, you need a new server, a new virtual machine to run a specific program for you. And you're probably going to need a lot of them. So you start with the first one. You say, okay, I need this processor. I need this many processors. I need this speed. I need this memory capacity. I need this storage capacity. I need this operating system, this database, so forth and so on. And when you're done, you've got your virtual machine and you spent a while putting it together. It's a very error-prone process. It's very easy to mess it up. Why not instead take all of those steps, specifying each thing that the virtual machine needs, and put them into a small piece of code? Then, whenever you need a virtual machine like that, you simply execute that piece of code and bam, brand new server, spun up instantly for you on the cloud. That's infrastructure as code. So the designs you like to use get put together in a little script. That script gets run and you have a new virtual machine. And if you need hundreds of them around the organization, you just run it 100 times. Everything is moving in that direction. We're trying to render everything you can control inside your environment as code that can be executed to give you what you need, when you need it, as quickly and as efficiently as is humanly possible. Another piece of the DevOps puzzle is Kubernetes, which of course is the management platform that orchestrates the movement of all of those containers with their microservices, orchestrates the movement around the cloud to where they have to go. Kubernetes has always been something that people typically ran on premises. Now it's available as a service from the cloud, making it much easier to gain access to. And Kubernetes reach has been extended to reach the edge, not just the core of the cloud network, but the edge of the network. So for those who are undertaking Internet of Things projects, deploying sensors and controls out there in the wild, woolly world, Kubernetes can help you manage all of that now better than ever before. Okay, so we've looked at all of the components, and as we started to say before, we've really defined DevOps, and of course DevSecOps, simply by adding security to the picture. There's also Cloud Ops. We're doing more and more with operations around cloud computing. The idea of infrastructure as code is a good example. AI Ops is very exciting. We're improving the way in which we manage the overall operation of the entire state, the entire digital estate, using artificial intelligence. Artificial intelligence helps us make better decisions about how much storage to deploy or what to look for, or when something may be going wrong, what an anomaly may be forming into an outage. AI Ops is accelerating the way in which we manage cloud computing. GitOps, a lot of people store their code in GitHub or similar services. GitOps helps you manage all of that. DataOps helps you manage big data. I mean, these are enormous databases that definitely need the management. And then ultimately, as we said before, we weave the entire thing together in BizDevOps. Or BizDevSecOps for those of you who've been listening. Ultimately, all of this is meant to achieve less ops. Yeah, less ops. Fewer people, fewer resources, bring costs down, and yet achieve more so that we can increase revenues. Fundamentally, this adheres to that age-old adage, which is that we have to do more with less. In this case, do even more with even less, far more with far less. And all of this automation is helping us do that. So that's the reason behind DevOps and all the other ops that we talk about. Leverage automation, leverage routinized processes to make things happen smoother, faster, better, and with fewer errors. That brings us back to where we started, which is our perpetual motion machine and the 4 transformation basics that we promised you at the top of this presentation. And although I wanted to go through them one at a time, they seem to insist on coming up all together. One is that digital transformation is about people, far more than it's about the technology itself. The technology is something we use, something we apply. Applied technology, like wisdom is knowledge applied. Well, this is technology applied to make life better for people where they live, work, and play. Transformation basics number 2, it's a continuous process. It's not a moment in time. It's not a thing you do. You don't do a digital transformation. You live transformation. And because you're doing that, you're getting better and better and better all the time. Continuous improvement. Again, that word of the day, continuous. Best enabled is more than best enabled. It's enabled by microservices and containers. When you're using cloud native programming, you have freedom to make things happen far faster than we ever could with monolithic coding. And so it's important that before you even think about a digitalization initiative, think about a cloud native software initiative. And then finally, all of this is about continuous improvement of really everything through continuous deployment and more development and delivery and deployment over and over again, iteratively getting better and better and better every time. If you think about it, the idea of being continuously improving things is the very best way to be more competitive in today's market. And the faster you do it, the more competitive you are. And with that, John, that kind of wraps this presentation up. Do we have any questions from the group?
Yes, my friend, we do indeed. Let's get some of those questions. I just want to remind attendees that they can type their questions into the Q&A box at any time. We'll do our very best to get to all of them. Let's start with this one here. What if you don't feel the need to transform? Our company has been running and growing successfully for years. Why would we want to transform? If it's working, shouldn't you not fix it?
Oh, boy. It's funny. That's a funny question because there came a time early on in the use of the word transformation. It was Microsoft. Microsoft was telling all of us who were Microsoft partners at that time that we had to go through business model transformation. We all had to experience a transformative experience. And I remember a lot of us saying something just like that. That, hey, I don't need to transform. Why transform if it's working? Well, we've done this for 20 years this way. We get better and better, but we don't have to pull out everything and put in something new. And there is a very high tendency to look at it that way. I don't. I finally stopped being one of those who bristled at the word transformation. Believe me, I was one of the loudest because I didn't think we had to transform. Terrific. What I realized is that it was a problem with nomenclature, choice of word. To me, when we talk about transformation, I really just translate that into improvement. No matter how long you've been doing something, no matter how good you are at it, there is very likely always room for some kind of improvement. And especially when you think about living in a world where new technology is emerging all the time. I mean, there have got to be ways in which we can apply that new technology to achieve new heights of greatness or new functions or new capabilities or what have you. And so if the world wants to call it a transformation, that's fine for them. I tend to talk about improvement or process improvement or structural improvement, strategic improvement, because I'm much more of a proponent of gradual change under control. I've seen companies try to change too fast and take themselves right out of business. The worst change is fast, uncontrolled change. You always want to manage change to be gradual and tested all along the way so that you know that you eventually do get to where you want to get to. And no, transformation is a bad word. Unfortunately, when you say digital improvement, people don't really react to it. The market has driven them to respond to the word digital transformation. So being totally transparent, I'm with you, whoever asked that question. I'd rather be saying digital improvement. Dead serious.
Okay, here's one. Any advice on ensuring security and compliance when using cloud infrastructure, as this can involve managing access controls and monitoring for threats?
Right. Well, this is not different from any other process that you commence in a computing environment. You absolutely have to be threat hunting. You absolutely have to have intrusion prevention measures in place and firewalls and authentication systems, authorization systems, anti-malware. You have to have all of that protection. That's why they added DevSecOps. Sec is kind of like a little teeny ad that's monumental. Remember, security exists at every layer of the ISO's 7-layer model. There is no security layer on that model because security has to be existent at every level and becomes a chain. whose weakest link is the determination of how strong the security is. In terms of encouraging compliance, my first reaction had something to do with a Louisville Slugger baseball bat, but I'm told we're not allowed to do that. No, seriously. I'm a believer that if you're going to change a culture, first of all, it's very difficult, almost impossible to change a culture. You have to evolve a culture. And I have found over time that the best way to evolve a culture, is to make sure that everybody who functions in that culture understands what's in it for them. Mm-hmm. People are always willing to make contributions. They're always willing to cooperate. Not always, but you know what I mean. But people are much more willing to participate when they know that participation benefits them too. This is one of the problems people have with just software application adoption. They don't tell the users, hey, this is what it does for you. The users think they just have to do it because the company demands it. And adoption is dragged out over years because of it. I think smart managers employ the very simple tool of informing their people. This is what the benefit is for you as we move to this new way of working. And then you'll see people comply because it's good for them. They want to comply. They don't have to be forced. So that's the way that I see evolving a culture.
Fascinating. Would you say that as part of that, this kind of covers a couple of extra questions we have here, that evolving that culture involves lots of training, or any training at all, or just getting people on board?
I guess that depends, right? Clearly, there's a base layer of functional training. Here's how to use the application. And once you've done the first iteration or two, that's probably done. From there, unless you make a major renovation to the application, that kind of training goes away. But I do think, as we were just talking about, helping people understand what's in it for them. I think a lot of companies don't do enough to make sure that their people always keep that in mind, that they're always encouraged to participate to their utmost, contribute to their utmost, because of the great benefit that's waiting for them in doing so. If that's bogus, you deserve to lose those people. But if it's genuine and you're building team by making sure that every player in the team knows what's at the end of the rainbow for them, man, that should work every time. And I guess you'd call that training. You'd call it acculturation. You'd call it managing. But if you don't understand if you don't understand how the thing you're doing contributes to the overall health of your company, which pays your salary, that's like the first step. If you don't have that, you don't have anything. So it's important that everybody understand how that whole process works, putting things in context.
Okay, my friend, here is kind of a big question. Enterprises typically enter the cloud with VMs as the mainstay. What is the argument to mature to containers and serverless? How do we create a policy about which platform to deploy?
Oh, there are many people arguing that question. Yeah, that is a big question. And I suppose that question will sort itself out over time. I think back when you asked that question to the days of file servers, when nobody had yet thought of servers running transactional software. And then all of a sudden, there was the precursor of ERP. There were accounting packages. And now we had transactions. And certainly the way you ran a transaction server was different from the way you ran a file server. I think that same difference is echoed here. That over time, we will gravitate to the place where virtual machines will be the equivalent of a file server. There's not really any, well, there's applications running there, but it's more about the data itself. And there's no way that a virtual machine can compete for the flexibility and the speed, the sheer speed of cloud-native microservices and containers. They are two very different mechanisms, and one is purely designed to run applications, and the other is designed to some extent to service those applications. So I suspect that it will break down that way. Well, I would love to get into a panel discussion about that one. Yeah, really.
Okay, here's a quick one. Can this all be done in a multi-cloud environment?
Sure. I don't know that. I would think that a multi-cloud environment would be even better because there's so many more places for those little containers to go. If you're using services from multiple different clouds, it may need to take advantage of those services, and it has them. It's available to them. I don't really think that multi-cloud is either a requirement nor is it a limiter. I think it can potentially serve up some nice enhancements, but it's certainly not. It's certainly not a requirement, and it's certainly not someplace you cannot venture. I suspect you would benefit from doing so. I haven't really thought about that.
Fascinating. Okay, here's a question that kind of covered. We've had several questions along these lines. What are some good digital transformation technologies we can use? People are looking for recommendations here.
Good digital transformation technologies. You know, the first thing I think about when you ask that question is HIPAA. Strange enough, right? HIPAA? Why HIPAA? I lived through the period of time where people were talking about how their product is HIPAA compliant. And eventually you have to laugh because there's no such thing. A product, any product, cannot be in and of itself HIPAA compliant or compliant with any given regulation. It is the overall operation of the company that is compliant or not. You can use tools, you can use different products to help you achieve HIPAA compliance, but there's no such thing as a HIPAA compliant product. Similarly, I can't think of anything that's really just a digital transformation product. Love to have somebody show me what I'm not thinking about, but
sure.
Yeah, we use the same tools. We just use them in different ways. Maybe some of the low-code, no-code platforms to be considered good digital transformation products. Maybe Kubernetes and Docker and all the other software you use in cloud native could be considered. But that's not all they're considered for. They're considered for other things as well. Anything that allows you to accelerate your processes and automate as much as possible and free up people to do more important work, that's a good digital transformation product or a product that contributes to digital transformation.